Alright, so the video got a little bit cut off, so I'm backtracking and I wrote some things that I didn't realize the video had gotten cut off. I ran out of storage. Anyway, so I ended up with this part of 5, 6. So where I left it was, I just went over here, I had already done the 3 times 5, that becomes 15. And as it turns out, when I take x to the 1/2 times x to the 1/3, I can make that x to the 5, 6. So that is what the answer to h of x is this. And I boxed it. I should put equals h of x next to it. So the next thing we need to do is evaluate the function h of 1. And there's two ways you can do it. One is you can go with, before we did any math to it, or you could go to the final answer and put it in. I don't know which is better. I truly think since we're more comfortable with square roots and cube roots than we are this, I would use this format. So that's what I did, is I just took this and I put it over here, and wherever there was a 1, or an x, I'm sorry, I put 1 in there. And when I did this, the 3 comes down, the square root of 1 is 1, there's my multiplying sign, there comes the 5, the cube root of 1 is also 1, and so when I multiply this up, I get h of 1. So you can technically also use your calculator, and there's two ways you can do it. One is you can just take this, obviously without that little wavy line in it, and put 1 in and take it to an exponent of 5, 6. So let me show you how you do that. So on your calculator, what I have over here on the left is what we're going to type in. I'm just going to do 15. Always put your base in parentheses, hit your exponent button, and then you can just put the 5, 6 in. Now, if you have the older operating system, then how you'll have to type it is like this: 15, parentheses 1, exponent button, and now you have to tell your calculator that all of 5, 6 is the exponent, so I just have to put that 5, 6 in parentheses. And then you get your answer. Either way, you're going to get 15, just like we got 15 doing it by hand. Okay? All right, let's try this next one, and then we're going to finish the last one together as a class. So we've got f of x, which is x to the 2/3, g of x, which is x to the 5/2, and we're supposed to multiply them, divide them, and then do a composition function. So let's multiply them first. So again, x to the 2/3 times x to the 5/2. And again, let's just take a look. Well, what am I supposed to do? I'm multiplying with powers, with exponents, and that says they have to have the same base. And again, the base is the x, the 2/3 and the 5/2. That's the exponent, that's the power. And I can add fractions. I'm just going to, realize that, make a little fraction over here. And again, I need to get my common denominator. It's 6 still. So I'll just take the fraction on the left to make that become a 6. I'll multiply numerator and denominator by 2. And over here, I'll multiply numerator and denominator by 3. And when I'm done, I get 4, 6. Over here, I get 15, 6. And when I'm done adding that, I get 19, 6. So when I'm done multiplying, I get x, let's put it up here, to the 19, 6 power. Now, again, your calculators can do all of this stuff. So let me show you on the calculator how you could do if you're not great with adding fractions. So what I could do is just, again, in parentheses, to let my calculator know that it's all a fraction. I could do 2/3. I could add 5/2. Hit enter, and it's going to give me a decimal, which is not what I'm looking for. I want it as a fraction, and if you actually press this math button here, and you choose that very first option, it's going to say, it's asking you, do you want me to take your answer and turn it into a fraction? And it will give you the most simplified fraction, and there's that 19/6, okay? So you don't have to be great with fractions in order to get through this section. All right, let's go to the next one, where we're going to divide them. So we're going to take x to the 2/3, and we're going to put it over, mess that one up. It's g of x, that's on top in the numerator. So x to the 5/2 is my numerator over x to the 2/3. So here, where we add the exponents, let's just go back to something simple that we know. Let's say it was just x to the 5th over x to the 2nd. So this would mean I have 5 x's on the numerator and 2 x's in the denominator, and then they could start to cancel out so that you're left with 3 x's, so x to the 3rd. So when you're multiplying, you add the exponents, but when you're dividing, you subtract the exponents. So 5 take away 2, that's where I get the x to the third. But we're not going to do that because not the same number. So instead what we're going to do is we're going to take these two fractions and we're going to subtract them. Well, the good news is we already got our common denominators. We've got 15/6 and we got 4/6. And I just have to take the 5/2, which is the 15/6, and I have to subtract the 2/3, which is the 4/6. And when I'm done subtracting these, I get 11/6. So the question is, gosh, well, I have two places where these can go. My answer, x to the 11/6, should it go in the numerator or in the denominator? So after you subtract, you should look where most of the x's were to start. So in this situation, most of my x's were in the numerator. So when I'm done and things cancel out, that's where the leftovers will be because the extras are in the numerator. So here, which is bigger, 5/2 or 2/3? 5/2 is bigger. So that means when I'm done subtracting, I still have the x's left in the numerator, and I'll just write it as x to the 11/6 power. So last one, let's do the composition function. So again, this means that we're going to take G's function, and we're going to put it into F's function. So first I'm just going to take this and replace it with what it's worth. So here comes the F. And G of x is worth x to the 5/2. And then I'm going to take this and put it right in there where the x is. So normally it's x to the 2/3. Now it's this to the 2/3 power. So this to the 2/3 power. So let's refresh our memory of how you do this. So we've discussed that's, when you're multiplying, you add the exponents. When you're dividing, you subtract the exponents. What happens when you take the exponent of an exponent? It's called the power of a power. Well, let's just switch it up to something that we know. If I have x to the 2nd power, and then all of that's to the 3rd power, that 3 means there's 3 of these. So 1, 2, and 3. And then those mean two x's for each set. And when I'm done and I add them all up, I realize, hey, I have 6 x's, which I can get 6x to the 6 if I just multiply. So sometimes you add the exponents, sometimes you subtract them, and sometimes you multiply them. And that's what's going to happen here, except here we're multiplying fractions. So let's just find a little spot. Let's take 5/2 times 2/3. Before I multiply, I like to see if I can simplify first. So I can't simplify 5/2 and I can't simplify 2/3, but I can simplify crisscross. These can cancel each other out. Divide by 2, and then just multiply across and get 5/3. So when I'm done, that's my exponent, and I have x to the 5/3 power. So add the exponents, subtract the exponents, multiply the exponents. You're just working with fractions. So when you add or subtract, you need a common denominator. And when you multiply, in the end, you always want the most simplified fraction. But you do not need common denominators here. And again, you can always do any fraction operation on your calculator. So you can take 5/2 times 2/3. I get this decimal. If I just press that math button and choose the very first option, it's kind of hard to see, but you get that 5/3 that I got. All right, so we're going to save this last one as a class.